Hi everyone, I'm Freya from City Sense. I'm Freya from City Sense Network Taipei. Welcome to the 2021 City Science Summit, co-hosted by MIT City Science and Taipei Tech, with all the members from City Science Network around the world. And here comes our third workshop of the summit. The workshop is hosted by MIT City Science. In this workshop, the MIT team will propose schematic ideas for a new model that could evaluate the potential of measuring the impact of hyperlocal solutions to global problems. So to further explore the issue, I'd like to welcome Kent Larson, the leader of this workshop, also the director of MIT City Science, to share more. Let's welcome Kent.
That's good.
Well, thank you, Fred. It's great to see everyone. I think we should just have fun with this workshop, and it's getting at some what I think are very important issues. And let me just share my screen and go through it very quickly. Why cities? This is an important question. Well, I think everybody on this call will realize that most of the population growth, most of the energy consumption, CO2 emissions, wealth creation, innovation will be centered in cities. Why should we think about this now? Well, everybody's aware of this, I think, IPCC report that came out that shows how critical it is to substantially cut emissions in the short term. And the evidence is all around us. We see fires in California, floods in Germany, vanishing glaciers. We're in the middle of a global pandemic, right? And these solutions are very challenging. It raises the question, well, where do we even start? And, a lot of attention right now is on national policy, things like carbon pricing. I don't think we can wait on our federal government to act, given how dysfunctional governments are around the world, although we do need action. Or the solutions involve exotic technology like carbon capture or fusion or whatever. How can people deal with that? Or the action is required in remote places like Amazon deforestation. But then there are local solutions at the community scale. So for this workshop, this is where we're focusing, what we think of as hyper-local solutions to global problems. The premise that we're working with here for this workshop is that the planet is becoming a network of cities. Successful cities will evolve into a network of high-performance communities, and the grand challenges of our era, whether it's climate change, public health, equity, jobs, are best addressed community by community. So we need action at many different scales, from the individual to the planet. But here we're focusing on these scales, the individual, the building, and the community scale. So what we believe in is a data-driven, evidence-based process. So for the purpose of that, we've built a kind of a schematic model to look at the impact of various interventions on the scale of the community. So Luis, everybody knows Luis, you'll hear from him in a minute, built this pretty amazing model specifically for this workshop. And let me step you through what this involves. So it's pretty overwhelming looking at this interface, but if you understand the pieces of it, I think you can relate to it. So right here are the mix of passenger vehicles, gas powered, hybrid, electric. And this is all, by the way, focused on Kendall Square and based on the MIT Transportation Survey and other data that we have available. So passenger vehicles. Here you can see the mix of delivery vehicles that serve the area. Here you can see the mix of different types of housing, because we're looking at housing innovation, so that's important. Up here, you see the basic demographics, the live work population and commuting patterns. And here you see the energy demand and the CO2 emissions summarized. This is the mix of energy fuel provided to the grid. So the tiny little bars in green are renewable energy, and the yellow, orange, and red are based on fossil fuel. So in Kendall Square, I think it's something like 78% of the energy delivered to the grid is from fossil fuels. This is what I'll highlight here in a minute, but the 6 primary interventions, there are others, but these I think are some of the important ones that we have modeled for the purpose of this workshop. And then this shows the energy production that's needed to meet the demand. So let me zoom in on that because it's kind of hard to read. But all these different bars refer to the use energy and the embodied energy of different sectors. So the top 2 is related to water, food, and sanitation. Then below that, energy related to delivery. Then the yellow bars are energy related to housing, and these are quite large. So you see the embodied energy would be the energy that is embodied in the structures and all the systems in housing, and the larger bar is the use energy. So this would be the consumption of energy for lighting and air conditioning, etc. And then the lower 2 are the energy related to vehicles, use energy and embodied energy. Then to the right of that, in the blue to gray shades, are related to the energy production needed, but these are the CO2 emissions. So that's really a function of the fuel that powers the various systems. Then down here is a radar plot. Those of you that have worked with our Cityscope knows really how we work with radar plots. So this is kind of a summary of the performance. And then this lower section looks at all of the new sources of energy: solar, natural gas, nuclear, fusion, etc. And it's also summarized over here in a little chart. Okay, so let's talk about reducing energy. So we can start with the percentage of electric vehicles, and you can see by dialing that all the way up to 100%, there is a a useful reduction in both embodied energy and use energy, but it's certainly not getting us there. And this is the main priority now of the current administration, is electric vehicles and electrifying the grid. Now, if we go to the second one, this is live work symmetry. You'll see a really dramatic reduction. This involves building diverse and affordable housing near where people work. So you're minimizing the need for commuting and, in fact, moving towards what we think of as net zero commuting. Much greater impact than just moving to electric vehicles. Then you can look at lightweight mobility modes. So the little video down in the lower right corner shows our PEV, the persuasive electric vehicle. So this is what we're talking about: replacing automobiles with lightweight mobility for both moving people and for delivery. This is particularly important when you combine that with live work symmetry and this next section, which is walkable access to amenities. So this is saying, what is the impact of having in close proximity to where people live and work all the amenities needed in daily life: schools, shopping, healthcare, recreation, cultural venues, etc. Then the next little box is looking at compact transformable housing. So the video you see on the lower right is one of the transformable systems that we first prototyped here in our lab, which is a space that dynamically converts from living to sleeping. So you effectively get rid of living rooms and bedrooms and use the same space for a combined function. And then local access to resources like growing food near the point of consumption or purifying water, dealing with sanitation. This little video shows our city farm project from about, what, 5 or 6 years ago. Okay, so then you need to increase the supply. So here we show dialing up the photovoltaics and solar all the way to the maximum potential. This would literally be covering every area that is available for photovoltaics in the district. But if you can see that there's still a need to tap into the grid, and the grid is primarily fossil fuels, so this is not getting us very far. In fact, it's a relatively minor impact. You could look at natural gas with carbon capture. This is great, but if you look right above that little box, you'll see that you rapidly consume a great deal of the area of this district, Kendall Square, with energy production facilities, which is not really practical. Or you have a whole series of evolving, emerging new energy sources like micronuclear, small nuclear reactors, or ultimately nuclear fusion, which might be commercialized in 15 or 20 years. All this is possible. So what are the challenges here? So if we move to all electric vehicles, this is a pretty relatively straightforward intervention in that it doesn't require a fundamental change in how we live, but it will require a rapid expansion of the grid. It will require tremendous expansion of electrical production. There are lots of industrial opportunities, so not surprising, this is a top priority for many politicians. If we move to live-work symmetry, we can see in this model that there's a tremendous benefit, but this will require new land use regulations, increased density, significant new construction, programs to create much more diverse and affordable housing than the market typically delivers. Walkable amenities requires also new land use regulations, programs to subsidize functions that are not supported by market forces. There's a good reason why Kendall Square doesn't have a pharmacy, because the rents are lower than other high value functions. So this would require some government interventions, market interventions, to make that work. Lightweight shared use mobility. This requires people to give up their private cars and will require significant behavior change, new infrastructure. But there's a high impact if it's paired with live-work symmetry and walkable amenities. Compact housing would require changes in the zoning, the relationships that people have to the home and their space. It would require new construction. And also local production of resources would require new land use regulations, probably carbon pricing. So you factor in the impact of transporting vegetables across the country or flying in avocados from Mexico. It would require building local supply chains. Then you have the zero carbon energy sources, as we talked about. It makes sense to maximize the available surfaces for photovoltaics, but this can only meet a small percentage of the demand, particularly if we move to all electric mobility, we process waste locally, we purify water locally. This will require lots of energy. Natural gas with carbon capture. Well, it is a fossil fuel, and less than 100% of the CO2 is captured with even the emerging technology. Micro and small modular nuclear, well, there is significant societal resistance and there's long-term waste to deal with. Many people think this is ultimately where we have to move in order to deal with the climate challenge, but there would be some real impediments to that. And then fusion. Fusion is fantastic in concept, but it's probably 20 to 25 years before commercialization. So this is our breakout group challenge, and we wanted to find a way to make it a little more real. So this is what we will challenge you all to think about in the breakout groups. Assume that a new mayor of Cambridge, Massachusetts was elected with a platform to aggressively transition to a low carbon future. Okay, your breakout group is a committee designated by the mayor, charged with developing the target goals, but you have to weigh the interest of all the diverse stakeholders, you know, environmentalists, the corporations, government, the current residents, and address the challenges of implementation, like cost, complexity, approvals, trust, behavior change. And this is a group that is working for the mayor, so you must consider these societal challenges, not just the technical challenges. So your group must issue a press release announcing this new program, and you must propose 4 things. One is your specific carbon reduction goals for each of those 6 sectors that are modeled on in the Excel spreadsheet, and you'll be given access to a copy of that. So number 2, propose the energy sources to meet that demand. So you will delineate how far you think that CO2 could be reduced. That will tell you how much energy demand you have to meet, and you must then delineate how you will get there. And then explain in this press release how you've met the concerns of the key stakeholders, how they've been considered, and then propose some branding strategy, like a name for the initiative. Now, this is a big task, but I think you all are up to it. So there are, we will have 6 breakout groups. There are 6 group facilitators: Maitane, Luis, Naroa, Alex, Marcus, and Ronan, all from the MIT City Science Group. And I think right now I would ask Luis to just say a few additional words about this model. So just to let everybody know what it is and also what it is not. So Luis, are you there?
Okay, thank you, Ken. Very quickly, I'm gonna share my screen. Do you see my presentation? I think I'm gonna jump directly to, because you have actually explained everything, but this is kind of the disclaimer, okay? So unfortunately, we don't have a crystal ball. If we had a crystal ball, probably we could be in, at the stock market, like making a lot of money. So what we have here is like it's a back of the envelope tool. So it has a lot of limitations, a lot of boundaries, and that's what I want to talk a little bit about. I think in the chat we have a very good conversation actually about this. So let me just go very quickly through very like few things. For instance, the model has this like, let's say, equivalence. We are working with back of the envelope numbers, ballpark figures, and we have extrapolations in data, and we also have like the population is actually fixed population, so we cannot have infinite population in Kendall, and the policies that we are working with, they are looking into 10 years policies, 10-year term policies. So there are some of these limitations there. Also, we have a simplification in the, let's say, how do we show the data? When we talk about CO2 or kilowatts hour, we are talking about equivalence, okay? So what that means? That means that in a step of having like a very complex like analysis of the gas emissions that we are producing, the convention today in the world is that we can say, okay, at 1 ton of CO2 is the equivalent of this 6% of nitrous oxide, methane, etc. So you take all these gases, these very dangerous gases into a basket, and you say this is the equivalent in CO2. In terms of kilowatts hour, actually is very similar. So we are showing here one kilowatt hour can be like the same amount of charging, I mean, like of a car moving 1.8 miles, but also like charging 86, let's say, cell phones. So as you can see, we are looking into not only electric energy, we are looking into like gas, etc. But we translate everything into this equivalent to electric. And 1 kilowatt hour of this electric energy is equal to 0.007 tons of CO2 equivalent. So that's a simplification. I know that this is maybe too technical, but I think this is important to know that we are talking about CO2 equivalents and kilowatts hour equivalents. That's important. Also, when we look into the impacts, we are looking into the life cycle of the entire of the buildings and vehicles that we are using and the policies. So what is this life cycle? This life cycle is that we are looking into the embodied energy from when you are extracting the raw material in nature, then you bring that material to the factory, you build the car or whatever, then that's part of the embodied energy because it's the energy that you need to produce the car. Then you have the operational energy, that is when the car is moving itself. And then when at the end of the life of the car and you have to recycle or trash the car, then we go back into the embodied energy because you need energy to just recycle the car. So that's kind of the life cycle of and that's how we are looking into that. In the middle of this slide, you can see all the different impacts and complex indicators that we have with the life cycle. So we have made a simplification, and we just talk about embodied energy. That's all the energy that you have to produce the car, extract the raw materials from nature, and recycle the car. And then we have the operational energy, that is when the car is being used, or the building, or the technology. So when Kent was talking to me, like, let's say 4 weeks ago, and he was like, Luis, what if we make this tool? I was like, yeah, Kent, maybe we can build something that gives you like the ballpark. I mean, I cannot give you like the ballpark figures, Kent. The best that I can do is this ballparkish figure. So it's not even ballpark, it's like a approximation of approximation. Why? Because we have the equivalents, we have the average numbers also. So we are talking about average consumption in the United States, average square meters in housing, etc., etc. We have a lot of linear correlations in the tool. We have a lot of extrapolations and some very few, but some educated guess. So again, this is not a crystal ball, but I think it's something very useful. We always say in the group, there is not I mean, all the models are run, but most of them, they are useful. So again, we are based the model into some databases that are kind of open source and accessible. Most of the data, they are based on, as Ken was explaining, on the MIT Survey Transportation. We have a fixed population. That's something important. So everything is a little bit more controlled in the Excel. So you cannot change the population. But what we have is the population can live outside of the neighborhood. That's the first bubble that we have here. So the starting population living in the neighborhood is almost 10K people. But then you can increase that population into almost 43K people. So that's something important. People living outside of the neighborhood, they have like big one-family houses, etc., etc. But when they get into the neighborhood, they start living into probably more efficient buildings, etc. So all these kind of movements are impacting into the Excel. The last thing that I want to show is that in the left, you can see how the energy consumption is increasing in the planet, and is like very exponential. And so we have translated that in maybe not that dramatically in the model, a little bit less dramatically, but the forecast that we have is increasing by 2.5%. I think the real rate is even is 10%, but even more. But in the model, we want to have that idea that if we do nothing, we are going to keep increasing the energy consumption, even if our cars are more efficient, even if the houses are more efficient. We make a more efficient car, but then you put more stuff in the car. So at the end, the weight is the same, and at the end, you are consuming the same or a little bit more energy, okay? That's one thing. And in the lower level of the graph of the slide, we have the how do we implement these policies. So we are implementing the policy, not everything in 1 year. So we are implementing little by little during the 10 years, okay? So you will see how the graphic gets into a reduction year by year in order to be a little bit more realistic. Like it's not like the government say, oh, let's do this today, and in 1 year you have everything deployed. So that's a little bit the things that I was interested talking about. I think Kent, he has covered the rest very well. So, and I don't want to like take more time. I think the most important thing is to play with the tool. And if you have any question, oh, another thing, the tool, yesterday I was debugging the tool with Kent, and he was finding a lot of small bugs, typos, etc. Again, we have made this like very quickly in 4 weeks. So if you see typos, actually you could document and tell me later, because that's very useful for me. So you're gonna be also a little bit debugging the tool for us.
Perfect. Thanks, Luis. All right, let's do the breakout groups. Remember that the mayor ran on this aggressive zero carbon platform. He wants Cambridge to be a model for the rest of the planet, but he's a politician and he doesn't want to get ahead of what is socially and economically practical. So your mission is to write this press release, okay? Have fun, and let's have everybody come back at 9:45. So a little over 30 minutes, okay?
It's always fast, isn't it? When we close rooms.
Yeah, a little
Hey,
bit
everybody,
without.
welcome back.
Is everyone back now?
We're back. This is us. This is our
Great.
group now.
Okay. Well, I hope everybody found it useful to take a couple of big giant steps back and sort of think holistically about possibilities. I realize that these issues are so complex that you can only begin to scratch the surface. But I think this, I think it's a useful exercise. So I'd like to hear what people came up with. So can we quickly go through what each group came to, starting
Yeah.
with group one?
And I see
Yeah.
that some folks did slides and some folks didn't, but I'll share my screen for those of you that did slides and then stop again for those of you that didn't. So
Okay.
first up is group one, and I believe this was led by Ronan. Did you have something else to say, Kent?
Yep.
No, go ahead.
Yep. So I think Patrick was going to share back for us.
Yeah. Hey everyone. So we didn't get too far. So we didn't get even to the energy sources, but for the 6 sectors, we talked about that quite a bit. I think we could have talked about it for a few more hours, but the consensus was that for electric vehicles, we thought 50% is a good middle ground, just because over 10 years, it's really hard to get rid of all the gas-powered vehicles, and it could be really costly for the people to kind of trade in their new vehicles for these electric variants. But we do think that for Kendall Square in particular, we need to increase the work symmetry. Just because there's a lot of commercial real estate here, and not a lot of housing here, or at least not a lot that's affordable. So we think that there's a lot of things to be said for that space. And then with that, we also wanted to increase lightweight mobility. Ideally, I wanted a bit higher, but there is there's a trade-off between, if it's feasible and if it's safe, right? And so as it stands right now, it's still not bulletproof. It could still be a little bit uneasy to kind of integrate these modalities with people. But we think 40% is a reasonable threshold for 10 years. And then of course for walkable amenities, if we want to, expand a little bit on the work symmetry, or to kind of persuade people to live here, we need to offer amenities that they have local to them. And for compact housing, we actually thought that not many people would prefer that. So we even thought maybe 10% is a bit generous. So we were kind of going back and forth and thinking like, how would, we, so like, I mean, to get work symmetry and to like bring more people into Kendall, we need to offer more housing, which would make it more dense, but we're not really sure that people would necessarily want compact living. So there's a trade-off there, and I think that's still open for discussion. And then lastly, for local resources, we thought that there's kind of a trade-off between kind of like the manufacturing at scale, where if we have more electric vehicles in 10 years and more autonomous delivery options, then there is something to be said about still keeping large farms active away from the city and getting those goods transported versus trying to convert small spaces into other kind of a local resource. And yeah, and then for the stakeholders, I mean, it's pretty much what's said there, and I, like for the environmental list, it's about the land required for local production. If we keep it kind of, if we reduce the amount of local resources, then we could if we keep how the manufacturing process is today, I think that kind of addresses their concerns. And yeah, and all that stuff. I'm not sure how much time I have, but yeah.
And here's how your metrics looked in the end for group 1. Anything you want to mention here, Patrick, or just what you were explaining before?
Yeah, I mean, pretty much on par. I mean, there's a lot more work that we need to do as a group, especially for defining the clean production route, but I think this is an okay first pass.
Great. Patrick, did you find this tool to be useful to help inform your policy recommendations, or was it too complex? What did you find?
Yeah, no, I mean, I think we all found it really interesting. And so we're actually able to see the impact of all these interventions. I think for me, I have more of a question of, okay, if I move this slider, what does it actually mean?
Sure.
What are the other inputs? And, there's a lot of
Right.
approximations, and I would love to know a little bit more about that. But as a first pass, I think this is very valuable.
Yeah. Yeah, I think you raise a good point. Kendall Square is a very special place. I mean, one could argue that we should not devote valuable land in Kendall Square to, food production, for example. Other people might even argue housing is inappropriate in Kendall Square, given the proximity to MIT and all the tech companies that are looking for offices. But anyway, this helps, sort of focus the conversation, I believe. Great. Why don't we, let's do group 2, Maggie.
Okay, so group 2 was led by Luis.
Yeah, but Diego, yeah.
Yeah. Hello, everyone. I didn't know about the number of my group, but here we are. We don't have the slide, and yeah, so maybe we cannot convince the mayor of our suggestions, but we still had a great discussion in our group that I wanted to summarize for everyone. So what we discussed about during our breakout rooms, it was basically we see that there are like two approaches that we can follow. The first one is that we can just generating maybe green energy with by solar panels or with nuclear energy, let's say. And yeah, of course, we will have less CO2 emissions, but maybe we won't solve we don't solve the problem. We go because we will move the problem just from the gas stations, so we will not use the gas anymore, but the problem will be to the grid. So we will need to generate lots of green energy, and it will take lots of money for the city. So it's something that maybe it's not so feasible for the mayor of the city or for the city government in general. And moreover, even if we want to think about like a situation where we will have 100% green energy, Still, there would be some issues. For instance, there would be lots of traffic issues because people will continue to use their cars. So there will be, we don't solve the traffic issue. People will lose lots of time commuting from their home to work or to other places such as hospitals, shops, and these kind of things. And we will have problems if we want to recycle, if we need, when we need to recycle, like solar panels, for instance, and these kind of things. And on the other hand, what we can do that maybe it's one of the best options is to changing the behavior of citizens. So maybe we can incentivize behaviors such as living closer to the working place. And but of course, in this situation, we need in this case, Kendall Square to maybe create new buildings, new residential buildings, and maybe give the opportunity to the people living there to have all the amenities they need in a walkable like distance. So maybe following the concept of the city of the 15 minutes, where everyone in a community have all the amenities they need in a maximum of 15 minutes walkable distance. And probably this will have a huge impact because people don't use their cars. People just walk to the place where they work and to important places such as hospitals. And however, like we still need to incentivize these behaviors. And maybe for these reasons, one of the ideas can be to follow like what the City and Science Lab at Shanghai presented before, like 2 hours ago, where maybe we can incentivize a local token economy where people that follow some pro-social behaviors can be rewarded by having in these local token economies. And yeah, of course, not everyone can live closer to the place where they work, so we still need to incentivize the adoption of electric vehicles and maybe especially vehicles such as the lightweight mobility vehicles like the PEV, especially maybe if we consider the delivery system, maybe the last mile delivery. And I don't know if someone in the group wants to add anything, or I hope I was able to summarize well what we
Thanks,
discussed.
Diego. Just looking at the bottom of this spreadsheet here, it looks like you have chosen to maximize the photovoltaics and solar and then wait on fusion. Is that fair to say?
That was so well. This screenshot is the result of just exploring a little bit. As you can
Just
see,
playing, okay, yeah.
yeah, we were playing because as you can see, we didn't change the lightweight, etc. But at the end of the conversation, we were talking a little bit about what if we try to have a fusion 100%, then we solve the problem, and that triggered the conversation about, okay, that solves the problem of the CO2 but doesn't solve the problem of mobility, etc. So that's why we trigger that so that is something that I mean, Diego and the team, they were talking about that, and that makes a lot of sense. It's like yes or yes, we have to combine a little bit the change of behavior plus clean energy somehow, because we have other problems than environmental impacts, also the mobility, etc. So I think that was a good conversation in that sense.
Great. Yeah, well, it looks like the mayor needs to give the committee another day or two to work through this. All right, group 3. Maggie, you're muted.
I think that's us, Marcus.
Yeah, yeah,
Okay.
we're here.
Do we have slides?
We have a slide.
A slide. Okay. So we had a very interesting conversation here. So first of all, well, there are two conflicting perspectives here. The first one is how to engineer the solution space so that you just maximize the reward. And the second perspective is the political one. So how could we make people accept and how we suggest feasible stuff to the whoever we are presenting this to. So the easiest and the most accepted proposition or suggestion was the one related to walkable amenities. We decided that it is pretty easy to convince everyone that we should have amenities within a walkable distance. We put that into 100%, yes. And the second suggestion we were talking about was this life work symmetry. So there was quite an interesting debate here. So we said, okay, the most effective action here would be just to intervene the prices of housing, let's say. But is that politically acceptable? In this case, in the US, so it's pretty country specific, of course, but that would be the most effective one, but probably quite difficult to achieve. So we suggested that maybe we could incentivize through taxes people living closer to their workspace. I mean, closer because maybe it's not possible for them to live within a walkable distance because of the price of the housing. And the second suggestion would be to incentivize working from home policy. That's it. So a working from home policy, maybe 2 days per week, so that not everyone has to commute on a daily basis. That's quite a tricky one as well, based on your work, like what kind of job you have, but well. And we thought that we should combine that with lightweight mobility. So if we achieve that considerable amount of people live within a walkable distance from their working place, then it makes sense to introduce lightweight mobility in that scenario. When it comes to clean production, we didn't get into a consensus here, not at all. So PV, solar, and wind, like renewable resources, sound really well, but there's a cost there, and we were wondering if it's very effective to have solar panels in Cambridge, given the climate there. And there was quite an interesting debate regarding the nuclear energy as well, because it's not the same having fission or fusion. But well, the greatest concern here was public acceptance. Like, would citizens be willing to have this kind of sources for their energy? So yeah, very conflicting perspectives there.
Okay, so
engineers on one side, the politicians on the other, and it was actually people closer to, I think in Asia, were much more concerned after Fukushima about, you know, the proposition of nuclear. That came up a couple times.
Right. Of course, Fukushima was ancient technology.
Yeah, but we're
compared to
politicians,
modern, but politicians, yeah, exactly. So
Yeah,
your committee reflected the lack of consensus that you find in society at large. So
Yep.
that's not surprising. All right, great, thank you. Let's do group 4.
And just so everyone knows, we aim to end at 10:10. I do think we'll run a bit over. We have 3 more groups to present. So we'll do our best, but group 4, you are up. Group 4 was led by Naroa. It's called Reimagining Kendall Square.
All right, so I'll take a lead here. So I'll be very crisp and brief. Ashish Panik right here. So we couldn't cover all the aspect of the projects, given the time limit here, especially the sources of energy, renewable energy. We couldn't get enough time, but we gave a try. So let me summarize, and I'll request my friends to kind of my teammates to chip in whenever required. So we started with kind of city contributes to 70% of the CO2, right? So meaning that city has to work hard to contribute to the sustainability project. So, and city will be housing more than 2.6 billion population by 2050. So we need to focus primarily on the housing aspect. So we picked up the housing sector as the number one contributor to our kind of plan, right? Sustainability plan. So the question is, we discussed, can we reconfigure the existing housing? The biggest impact would be people. It's going to impact the lifestyle, and it is also going to impact the behavior of the citizen or the people itself. So we thought maybe technology can help, and the target population could be the young professionals who will be starting career and who may not be needing a bigger house and bigger setup. So that was, we thought we should target that young professionals to start with. I think the live work symmetry was an interesting discussion. We said we should aim for 100%. We discussed about the pre-COVID when it was 100% was not kind of it was not possible type. But when we saw in the post-COVID, working from home is default, and a lot of the travel could have been avoided, right? So we maximize that to 100%. Maybe some of the manufacturing professions need kind of travel to the workplace, but we are very optimistic that we can maximize that one. I just covered the kind of the vehicle, electric vehicle. Again, what we looked at the practical problem as well, right? So what will happen to the existing vehicles? So one is we try to combine the EV, the electric vehicle, and the lightweight mobility, because both they go hand in hand. The EV alone cannot solve the problem, because it may solve the problem of the kind of renewable energy, replacing the fossil fuel with electric, but it's still going to crowd the road and the infrastructure, burdening the infra. So we picked those two together, and we thought maybe more than EV, also lightweight mobility options like robotics, autonomous vehicle could bring a big difference here. And maybe I'll just touch upon the last one, the local resources. Even we put it kind of 30%. We wanted to go more than this, but this is going to the impact the existing supply chain, right? The way the goods are being sourced and distributed within the city, and also it needs a little or more planning exercise on the supply chain side as well. So it will be a little difficult or the tricky stuff. We thought as a team. And on the energy sources, I just tried to kind of I'll just touch upon that. We said we should maximize it, and we had a debate on wind, solar versus nuclear. I think one of the group also mentioned the similar stuff, and we had kind of a debate that nuclear could be the cheapest option, but maybe may not be acceptable because of the horror story we hear, right? But if it is handled rightly, the technology can help to kind of promote the nuclear energy as well as a main source of the energy to fuel the city's need and all. So that is, and if you look at, so we could hit 75% the carbon savings here. Maybe we thought maybe maybe in the next round we could further optimize these numbers.
Great.
Yeah.
Excellent. Good. We're right at 10:10. Let's try to wrap up with the final two groups.
Some more notes here, so we'll have to
Oh
review
wow.
this.
Okay. Good.
Lots
All
of
right.
information here. And
Looks
then
looks like this committee's almost ready to issue a press release. All right. All right.
Group
Citizen
5.
first, efficient neighborhoods. I like it. Go.
Yeah. So I'm gonna be reporting for the group. I will be quick because we are running late. So we wanted to reduce 100% the CO2 improvement and the energy improvement. So that's why we focus on electric vehicles, live work symmetry, and compact housing, and that's why we increases like 70% each. Then in energy sources, we try to rely on the technologies that the people accept right now. So that's why we increase like 30% the PV and wind energy, 50% the natural gas with CO2 capture, and we try to also increase like 10% the nuclear energy, the categories. But I don't know why some parameter went red. So I think that's not good. So I don't know. I want to understand also maybe later with Luis how this parameter works with the energy sources. And then some concerns that we talk about are that we if we provide more compact housing, the transportation and the mobility will be cut down. Also, we were talking about what people care about, and it's about like commute times and the cost of the interventions. So that's why we propose. I mean, we propose this. The name of the initiative is Citizen First Efficient Neighborhood, because I mean I think the solution should be like centered in people. And yeah, I think that's all of what we talk about.
Great.
Yeah, this is more or less our proposal.
The thing went in red because you ran out of space for building energy devices in the neighborhood. 61. You're investing 61% of the land in energy in this kind of factory of energy in this. Yeah.
Okay. Okay. Thank you, Luis.
Great. Thank you, Maitane. Okay, last group is group 6. This was led by Alex.
Hi, yes, one of our group members named Chingling is going to report back.
Yes, so well, our group haven't not quite make a conclusion yet, but we can talk about some of our discussions and thoughts. So our group 6 is closer communities for carbon dioxide reduction. I guess the stakeholders in our group 6 really value the time they spend. Residents are concerned about the commuting time, and shop owners are very concerned about delivery times. Thus, we are thinking about like live-work symmetry is quite important in our group, and we want like 50% carbon dioxide reduction from this part. And we also think electric vehicles might not help reduce carbon dioxide a lot in less than 10 years. So this part we think is like about 20%. And we're also thinking about like compact housing like has a 30% ratio, as there might be a certain amount of single people in Kendall Square. And therefore residents might need more dedicated space for resource productions. And therefore we are thinking about developing some energies like solar and biomass, since like it's easy to produce. Like, yeah, I think that's our discussions what we have now, and maybe my teammates could like add more comments.
Yeah, like Chingling was saying, our focus was on things that are practical and things that are local, and that's why for energy production, we were focused on increasing the use of biomass and solar. Raquel, did you have anything you wanted to add? Thanks, everyone.
Great. Thank you, group 6.
Great, thanks everyone. Well, we're just a couple of minutes over, but I just want to thank everyone for participating, and just mention that what motivated this. There's a lot of discussion these days about zero carbon. Many articles written about it. Much of the conversation is simplistic. Typically, you read that people argue that if we deploy solar and wind and electric vehicles, will solve the problem. But if this workshop increased the awareness of what is actually needed, what is possible, what the challenges are to actually achieve something close to zero carbon, then I would consider it a success. So thank you all again for participating. Luis, you want to say any last words?
No, thank you, everyone. Thank you. Yeah, I think it was I have a lot of fun during the workshop. So thank you, everyone. And I think every group has something important to say. And at the end of the day, this opened the conversation. And well, That's it. Thank you, Kent.
Okay. All right, everybody. We'll see you at the next workshop, hopefully. Have a great
Thanks,
day.
everyone. Thanks for
Bye.
joining. We hope to see some of you tomorrow.